In this video, we will be going through the entirety of the first quantitative section of ETS GRE PowerPrep exam number 2 that is freely available from their website. But to start this video, I want to make sure you know where to find this exam. So on their Shop GRE Test Prep webpage, you're going to have to scroll down all the way to the bottom, past all of the for sale items, and get to this other category. And once you get down here, you're going to have to click this arrow all the way to the far right, and you'll finally find PowerPrep 2 timed practice test that is freely available. I've already opened this, so we'll go ahead and pull it up here in this window. And you can see we've got the quantitative reasoning section. I'm kind of framing things a little bit differently than you normally would, just so you can see my scratch work here on the right for the problems, but you can see it's going to take 21 minutes to go through 12 questions. That's always the structure of this first quantitative reasoning section of the GRE as it is currently comprised. And we're going to just click continue and see our first question. So one thing we need to do consistently is engage our scratch work. So I'm going to set up choice or quantity A, quantity B here over to the right. And I'm going to set my answer choices A, B, C, D in the middle. So I know that they are correlating always with greater than. Choice A means that quantity A is always greater than. Choice B means that quantity B is always greater than. Choice C means the two quantities are equal. And then I put a little NA over top for not always is the relationship consistent. So I need to go to the quantities first, and that little line over top means repeating. So I'm going to just write this out a couple of times. We've got 7, 1, 7, and then it'll be 7, 1, 7, and then over here we're going to have 7, 1, 7, 1, 7, 1. And I should recognize that there's a distinction here at the fourth term. And 7177 is going to be greater than 7171. So that means that our correct answer is choice A. I will select that. And what I could do is I could actually keep my scratch work here consistent, especially if you're using your own whiteboard at home. So now we're going to just look at the next question. We've got quantity A, which is the slope of line J. I'm just going to put slope J, and then we've got the slope of line K. And I'm going to do my best to avoid drawing really here. But I could draw a really simple little coordinate plane up top for clear reference. And it says in the XY plane, the point 1, 2 is on line J. Okay, so I'm going to have we'll just have 1, 2, and then 1, 2 here. So 1, 2, that's going to be the point on line J here. And I'll scroll up just a little bit. And then 2, 1 is going to be on line K, if this were the origin here. And we'll just say 0, 0. I just have 1 point for each of these lines. I have absolutely no idea how they relate to each other. So that means that I can't determine what the relationship is. I'll select that and I'll move on very briskly. So then we'll just clear out what we had underneath the structure for our scratch work on the quantitative comparisons. Now, this one, we've got the circumference of the largest circle. So I'm going to write that as just the actual formula. So I could see that the largest circle I could just define as the line PQ as the diameter. And it says the centers are on that line. So I know that the formula for a circumference of a circle using diameter is just going to be pi times that diameter. So quantity A I can write as PQ, the line segment, times pi. Then the sum of the circumferences of the two smaller circles, well, I can write that as PR for one of the two smaller circles times pi, plus I can then have RQ, the line segment, times pi. Now, the best position for the quantitative comparisons is going to be to manipulate manually through technical algebra or arithmetic. And I should recognize the possibility that I could factor a pi out of both of those two pieces in quantity B, which would leave me with PR plus line segment RQ. And then I should recognize, well, PR plus RQ is just going to be pi times line segment PQ. These things have to be equal, and I don't actually have to draw anything, model anything, plug in anything. We select C, and again, we can move right on to our next question. We'll clear out the work underneath for ease of use of that structure once more, and we can see we've got our first notes up top that we'll have to take. So we're going to have k here, we're going to have -2 over here, and we know k is an integer for which that 1 over 2, 1 minus k is less than 1 over 8. So here is one of those situations where I can do this a couple of ways. So if we're not sure of the technical solution, if we just said if k equals -2, well, then we're going to have 1 over 2 to the 1 minus -2, which is going to be 2 to the third, which is going to become 8. And 1/8 is equal to 1/8. It's not less than 1/8. So we know right now that these two quantities, they are not capable of being equal. So we can eliminate that. And then we've got to determine which direction our k has to go. So if k were less than -2, well, then we could make k equal, say, -3. And then we'd have 1 over 2 to the 1 minus -3. And we'll just say k equals -3 here so we can remember it and see it in full. But then we're going to have 1 over 2 to the 4th, which is going to be 16th, and that is less than 1/8. And we've discovered the relationship whereby quantity b has to be the greater of the two values in order for that initial inequality to work out the way that it should. Now, that said, we can do our technical alternative. So we could also set it up so that we've got 1 over 2 to the 1 minus k is less than 1 over 2 to the third. And then because both of these values are going to be positive, we can just cross multiply and keep our inequality sign. So we're going to have 2 to the third has to be less than 2 to the 1 minus k. And because the bases are consistent, we know that 3 has to be less than 1 minus k. We just will then, and we'll scroll down just a little bit so we can see it a little bit better, give me some room. We'll add k, we'll subtract 3, and subtract 3, and we discover that k has to be less than -2, which is the exact thing we came up with through our model. And either way, quantity b has to be the greater of the two quantities, and we'll move on to the next question. And since we are into a quantitative or a standard problem solving question, we can get rid of our little quantitative comparison structure there. We're going to set up our answer choices A, B, C, D, E, put a little line over top, and we're being asked for what C is equal to. And I've got real numbers, 1, 0, -1, -2, -3. But if I have clear algebraic structures, I'm going to want to try to do this technically as opposed to potentially using an alternative tactic, just because it's probably the technical that's going to be fastest. So first thing I always want to do is get rid of fractions. So I'm going to just mentally multiply this first equation by c plus d to simplify it. So we're going to have c minus d is equal to 2c plus 2d. Then we know that d is being described as 1. So I'm going to just plug in if d is equal to 1. Well, now I'm going to have c minus 1 is equal to 2c plus 2 times 1, which is 2. So then it's just a matter of subtracting 2 from both sides and subtracting c from both sides. We've got the c's cancel out. -1 minus 2, not minus 2. That minus was with our c. Got to be careful there. But we're going to end up with -3. And then 2c minus c equals just the 1c. And there is our solution for this question of -3. Moving on to the next problem, we've got our data interpretation set. And you can see I just zoomed out a little bit for ease of use. And what I have to do here is understand the information in the tables first. So I'm not even going to really engage with the question and answer yet. I just need to know what I'm looking at. And so on the left-hand side, I can see some median home prices in the US by selected region. We got regions, we got median home prices in 83, and then there's some percent change happening. I don't need to get into the details, but I can see that's from 83 to 86. And then we change our median home prices for just the northeastern cities in 1986. So we can see monthly housing costs, a bunch of different prices of home, and we can see how it's basically organized is ordering in terms of the price of the home from the highest to the lowest. So starting with the setup, we're going to write out our answer choices just for clear reference, and we're being asked for which of the cities in 1986, which means we're looking at the second chart, the one on the bottom, was the median home price minus the median down payment greatest. So we're looking for median HP minus the median DP greatest. So we've just got to go find that gap, basically. And I can use the calculator if I'm so inclined, but I'd really rather not. So I should be able to eyeball some of these answer choices as basically being eliminated. So we'll just grab a little red color there for that. So if we're looking at New York, I go, okay, that seems pretty big, right? There's a big gap there. But when I'm comparing against Boston, I go, Boston's price of home only goes down about $3,700, but the down payment cost goes down a lot more. So I'm just going to eliminate A based on that evaluation without even doing it fully. Similarly, if I'm looking at Newark versus Boston, well, the Newark price of the home went down a bunch, but it didn't even go down $1,000 in terms of down payment. So Newark's going to be out too. And I can see that this distinction is $96,000 at this point. Danbury isn't even worth $96,000. So that price of home is going to be gone immediately, because even if the down payment was zero, it's less than the 96,000 difference between Boston, the price of the home in Boston and the down payment in Boston. And then lastly, Pittsburgh, again, way too low. So our correct answer is B, and hopefully we don't spend nearly as much time as I did working through that problem on the actual exam. Next, we can see we've got another one asking about a very specific thing. So we want to know the median home price in Danbury was approximately how many times the median home price in Trenton. So we got A, B, C, D, E, line over top. We're just going to put equals question mark, because really my Danbury median home price was $95,950. And that's going to be equal to the median home price in Trenton, which is $66,000. And then we've got times X. Go ahead and use the calculator. This is what our friend the terrible calculator was made for. He's never had a better opportunity to shine. You can move it down here just so that it's out of the way, but I'm going to just divide that 95,950 by the 66,000, and I've got 1.45, and that's going to be 1.5 times closest, so there's our correct answer. Make sure you pick correctly. It's 1.5 times, not 1 2/3 times. But there's going to be a correct answer for number 7. And then we've got one more of these questions pertaining to this little pair of charts. So looking solely at Newark in 86, what was the approximate ratio of the median annual housing cost? So we want median yearly HC to the median annual income. And they don't accidentally put that little underline there. You have to recognize that little underline. And so once again, I've got to do a little bit of math, because in Newark, we know that the monthly housing cost was 1139. So I'm going to just take out the calculator again, 1139, multiply that by the 12 months of the year to figure out that the median yearly housing cost is 13,668. And then we just come down here to Newark once more, which is going to be my 54,660, 54,660. I'm going to use the calculator once again, 54,660. And there's my 25%, or 1/4. We can select that and move on to the next question. Here we once again have a rather direct technical manipulation that, if you understand how to do it, shouldn't take you that long. So we're going to just set up our scratch work. But I also want to note some things logically. Well, first off, I should note I've got a different number of 2's in the denominator and a different number of 3's in the denominator. So that means that I'm more than likely going to need a different number of 2's and a different number of 3's in my solution. So let's get rid of A, let's get rid of B, let's get rid of E, knowing that there's not the same number of 2's and 3's in the denominator, and we're all working off of the same numerator, just one base. So that's a great way to logically estimate this if you're not certain. Similarly, I'm looking at it and going, it's probably not going to end up where there's a ton more 2's, 7 more 2's than 3's. So C seems unlikely. And I can get to the right answer of D just through some logical evaluation. But if you recognize the way in which you can factor 6, well, you can rewrite that as 2 to the 14th times 3 to the 14th all over 2 to the 5th times 3 to the 7th. And hopefully you remember that if you have bases that are being divided, you subtract the exponents. So I'm going to end up with 14 minus 5, 2 to the 9th, 14 minus 7, 3 to the 7th, which of course is the exact same as choice D as well. Moving on to the next question. Right here, we've got one of the best opportunities for modeling you'll ever see. So we're going to set it up A, B, C, D, E, put a little line over top. We're being asked for the hours to travel Y miles. So the key indicator here is just the litany of answer choices with variables. So I know I'm going to not try to do this algebraically. They're hiding all of the math with the English. So let's just set up a model and see what happens and select the correct answer. So train is traveling at a constant rate. Train travels S is some number of miles in T some number of hours. And then it asks, in how many hours will the train travel Y miles? So let's just do 10 miles in 2 hours, and let's just say Y equals, let's go with, say, 30 miles. Well, then it's going to do that in 6 hours. So we need to find an answer choice that gives me 6 when we plug in 10 for S, 2 for T, and 30 for Y. So S times Y is going to be 300 divided by 2 is most certainly not 6. That's out. S times T is going to be 20 divided by 30. That's not even 1. That's out. T times Y is going to be my 60, and then divided by my 10, and I go, ooh, that's exactly the 6 that we were seeking. Got to check all of the answer choices if you're modeling just to be sure, but if I put 10 over 60, that's going to be something that is, again, less than 1, definitely not the correct answer. And if I did S plus Y, I get 40 divided by 2, that's going to be 20. And so, once again, we've got our correct answer, but through a method of modeling, not necessarily the technical solution this time. Here, however, we are going to need some technical math. So we skip to the end of the problem, as we should always with the GRE, and we see what we're being asked for is just the value of P. And I've got real numbers, even though they're fractions. I'm probably inclined to write them out. 4/7 and 5/7. Even with the timer going down, you just have to remain calm. So, certain experiment has 3 possible outcomes. The outcomes are mutually exclusive and have probabilities of P, P over 2, and P over 4, respectively. Well, we should remember that the sum of all probabilities for an event is equal to 1. So that means that P plus P over 2 plus P over 4 has to be equal to 1. And anytime you've got algebra involving fractions, just multiply by the least common denominator to get rid of the fractions in one fell swoop. So now we're going to have 4P plus 2P plus P is equal to 4. We now have 7P is equal to 4. And we just divide by 7. And we discover that the solution here, P is equal to 4/7. And that's our correct answer. Moving on to the last problem of the set. Now, this is probably the only time I might encourage drawing. Now, I am going to want to figure out what I'm being asked for first. I'm going to just put it up here for clear reference, put it in a box. I want to know what X is. But if you're going to draw, what you have to do is draw one piece at a time and be very careful. So I'm going to kind of draw this big. I've got this little right angle piece first. So I know that there's a right angle down here, which means that there's a 90-degree angle. And then I've got this piece here that I need to connect, actually. Let's make sure that we actually connect these two pieces. There we go. There we go. There we go. Good enough. And so then we've got a 30-degree angle up here, and that means that we have to have a 60-degree angle down here, because all triangles have 180 degrees. Then I should recognize that this length here had been extended, actually. So let me just kind of cheat by sending it out a bit more. And then we're going to draw our last line that just kind of goes like this. And since I know that that's a 60 where we just drew our first of the triangles, there has to be 120 degrees right here, because that's going to be a 180-degree line. And then we've got a 40-degree angle up here, which means that there has to be another 20 degrees down here. And if there's 20 degrees here, well, then our X has to be equal to 180 minus 20. There's our 160 degrees. And if I really wanted to prove this out, I could end up figuring out that this has to be 20 degrees as well, and then that's going to have to be 130, and so on and so forth. But I don't need to. I've got the solution. And when you've got a numeric entry, you just come over here, type in the correct answer. You've got 160. And then when you're done with the section, you'll hit next. And you can come to this little review button and see all the questions. Do this because you might find something like I just did, that in number 6, I didn't select an answer. And I should recall that this was where the median home price minus the median down payment was supposed to be the greatest. That was my Boston. So great little catch there, actually. And now I can go back to the review screen, make sure that I've answered everything, and then you will just have to click next ultimately. Once I hit go to question, I can then hit next, and then I hit continue, and I am now done with the section and would move on to the second verbal reasoning section of GRE Practice Test 2, which we'll address in another video.